all, let we learn about minimization of Boolean functions using Boolean algebra laws and theorems. So we need to follow some procedure for simplifying your Boolean expressions using laws as well as your theorems of Boolean algebra. The step 1 is multiply all the variables required for removing your parentheses. Step 2 is find all the identical terms in the expression. Only one of those terms must be kept in your minimal expression and the remaining will be dropped. For example, so now I have a product term ABC arrived 3 times in a given expression. Now only I'll keep one product term in my minimal expression and the remaining 2 must be dropped. So step 3. So we are calling that as a redundant terms, which are repeated terms of your expressions are called as redundant. Redundant terms must be discarded and only we have to keep one product term or your one sum term. Step 3 is find a variable and its negation in the same term. This term will be dropped with a 0. For example, now I have a product term A and of B and of B bar and of C. So always check for a variable which is ANDed with the complement of the same variable in a product term. So then it must be dropped with a 0. Now B and of B bar using AND law. So it is replaced with a 0. A and of 0 and of 0 and of C is equal to 0. So step 4 is identify the pair of terms which are identical except in one variable that may be missing in one of the term. So in this case, so we can drop that. So with taking your common variable and now, so it can be explained with this example. ABC is my product term which is having 3 variables or of AB. So which is having only 2 variables. Out of these 2 product term, AB is a common variable. Let I take AB as common variable. Then we have C or of 1. So 1 or of C or C or of 1 is always it is equal to 1. So AB and of 1 it become AB. So next step 5 is identify those pairs of terms that have the same variables with one or more variables complemented. If a variable in one of the term such a pair is complemented and in the second term it is not complemented, then such terms are combined into a single term with that variable dropped. For example, now ABC or of ABC bar. So only one variable is different from this 2 product term. So in first product term it is uncomplemented variable of C. The second product term it is complemented variable of C. So now out of these 2, AB I have taken as common. So C or of C bar. Then C or of C bar is 1 replaced with 1. So we have AB. So like this we have to always check for here these steps. Okay, 5 steps we need to follow for minimizing your function, as well as we need to use the suitable laws and theorem in your each step. Then we will find your Boolean expressions which can be implemented with less number of gates after minimization. Now, so let me proceed with this by using the basic foremost steps, as well as so we are going to use the laws and theorems for minimizing. So now your given function f1 is defined as x bar y bar z, x bar y z, x y bar. Out of this first and second term, so we have a common variables x bar z, here also x bar z. So only one variable is not common. In first product term it is complemented, in the second product term it is uncommon. So hence take your x bar z is common, then y bar or of y or of x y bar. So as y bar or of y is 1, so we have x bar z or of x y bar. So now take another example. So a or of a bar b. So you are using your distributive law, a or of a bar and of a or of b. As a or of a bar is 1, so 1 and of a or of b is minimal expression is a or of b. F3 is your function in another example. So F3 let I define this as a or of AB. So using distributive law, a or of a or of b. So now or take a as common variable, then I have 1 or of b. 1 or of b using your or laws. So it is always it is equal to 1. So hence here a and of 1 is equal to a. So Another example, so example 2 I have taken for simplification of expression. So P bar and of P or of Q R or of Q bar R. First step we will use, so we will remove the parenthesis by multiplying its variable. P bar P or of P bar Q R or of Q bar R. So P bar P, so it is AND operation between a complementary and complementary variable is replaced with 0. So from your second product term and third product term, now we have taken R as common, P bar Q or of Q bar. So now here we have a variable and its complemented variable with a OR operation. So now we will use the distributive law here. So if I use the distributive law, so Q R of Q bar, P bar R of Q bar. So Q R of Q bar is replaced with 1, P bar R of Q bar. So now if I multiply this, so we will have P bar R of R Q bar. Finding the simplified expression of A bar and of M bar or of A bar, M or of M bar A. So now let me remove the parenthesis using your distributive law, the last one, the last sum term we are going to distribute this. So by removing the parenthesis, M or of M bar, M or of A. M or of M bar is 1, 1 and of 1, M or of A is M or of A. So A bar, M bar or of A bar. So now let me multiply your M bar or of A bar with M or of A. So M bar and of M, M bar and of A bar and of M, A bar A. So as here we have an AND operation between a variable and its complement. Here also M is ANDed with M bar. So which are replaced with zeros. Then we obtain here A bar and of A, M bar. And here we obtain here A bar and of M. So now A bar A is replaced with 0 and here A bar is equal to M A bar. So this is the final minimal expression that we obtained from this expression. So next, another example I have given here. So total 7 product terms. So out of this 7 product terms, let me verify which are the common variables. So let me take ABC bar as a common, D bar or of D, and the third product term is taken as it is. AB in ABCD, in AB bar CD, ACD is common, B or of B bar. In these last two terms, ABCD bar, AB bar C D bar. So your common variables are AC D bar is taken common, B or of B bar. So replace D bar or of D, B or of B bar, B or of B bar with logical one. Then we have ABC bar, AB bar C bar D, ACD, ACD bar. So from this last two product term, AC is taken as common, D or of D bar. So we got it as here AC. Now, so A, B, C bar or of A, B bar, C bar, D. So from the first and third term, so we have a common variable A, B, C bar or of C or of A, B bar, C, D. Now, so C or of C bar is 1. So B or of C we will get. So using your distributive law, so A and of B or of C or of A, B bar, C bar, D. So now let me remove the parenthesis AB or of AC or of AB bar, C bar, D. So now here also from the last and first term, so we have taken A common, B or of B bar, C bar, D. So or of AC. So now A and of B or of B bar and of B or of C bar, D. So now B or of B bar is replaced with 1. Now we have only the sum term B or of C bar, D. So or of AC. So now AB, so or of AC bar, D, AC. So now AB is or of A and of C or of C bar D. So here also we use the distributor. C or of C bar is replaced with 1 and C or of D. So now we obtain the final expression is AB or of AC or of AD. So which is our final expression here. So minimal expression is equal to AB or of AC or of AD is our minimal expression of your given example. So with this, so we minimized these many 7 product terms into three product terms with only two input variables a, b, ac are of ad. Next, we will move to your minimization of your function using your Boolean laws with example 5. F is equal to AB or of BC or of B bar C. So now here C is taken as common, B or of B bar. So B or of B bar is replaced with 1. Hence we have only three variable. So three variable or a two product terms A, B or of C. So another example we have taken as A f is equal to a or of a bar b using your distributive law a or of a bar and of a or of b. A or of a bar is replaced with 1. So we obtain a or of b. So next another example. So f is equal to with three product terms a bar b bar c or of a bar b c or of a b bar. So out of this first 2, so we have a common variables of a bar c is taken as common, b bar or of b or of a bar. So b or of b bar is replaced with 1. So then we have a bar c or of a b bar. Next, simplifying your expression ab or of ac whole bar or of ab bar c and of ab or of c. Now let me remove the parenthesis first. So ab or of ac bar or of ab bar c, ab or of c. So now using your De Morgan's theorem, so AC whole bar is equal to A bar or of C bar or of AB bar C. So here we verified that so common variables are here. It is B bar is multiplied ANDed with your B, and here so as well as here A and with your A. So now this can be dropped with a 0. Next AB bar C and of C, so which become AB bar C. So now upon having this, so AB or of A bar C bar or of 0 or of AB bar C. So ABC, so ABC or of AB bar AB C bar or of A bar C bar plus of AB bar C. So now here, so AC is taken as common, AC is taken as common, B or of B bar. So or of C bar is taken as common. So as AB or of 1. So or of AB bar. So hence here AC is AC and of B or of B bar become 1. So or of C bar or of A bar. Now I can write this C bar or of A bar as AC complement AC or of AC bar is equal to logical 1. Next, we were going to find your minimal expression of this x bar y, xy bar, xy. So from this first two product, first and last product, y is taken as common, x bar or of x. So x bar or of x is replaced with 1. So y or of xy bar, again distributive law we are going to use. So x or of y, y bar or of y. So y bar or of y is 1. So x or of y. So next, so last example we have taken as f of w x y z is equal to w bar x bar y bar z bar plus or of w bar x bar y bar z or of w x bar y bar. So now from your first and second term take your w bar x bar y bar as common, z bar or of z is replaced with logical 1, w and of x bar and of y bar. So w bar x bar y bar or of w x bar y bar. From these two terms x bar y bar is taken as common, then w bar or of w bar or of w is replaced with logic 1. The final minimal expression is x bar and of y bar. So using your Boolean laws and theorems, we're going to minimize your functions to minimum number of letters. With that, with less number of utilization of logical gates, we can implement or design your digital circuit. In the next class, we're going to learn about your the function representation using standard and canonical forms. Thank you.